Okay, this is guide sheet number 2. This is going to try to cover the difficult concept of how inertia works when you're moving in circles. When you're moving in a circle, we call it a non-inertial frame of reference. That means that the law of inertia does not seem to hold while you are inside that circular motion. We'll see why it actually does hold and why it seems like it doesn't as we move along. So, a quick review, and again, circular motion, great way to review a lot of the things that we've done so far. The first law, the law of inertia, says an object at rest will remain at rest. An object in motion will move at a constant velocity. Now that means it must move in a straight line at constant speed, unless acted upon by an unbalanced force. Inertia is the property of matter that resists changes in motion. Now that goes both ways. It makes it harder to push something if it has inertia, and it also makes it harder to stop if it has inertia. So we're going to look at a few applications of Newton's first law, the law of inertia, in circles. We've got a driver and passenger. The passenger's in blue, the driver's in the X, and they're going to make a right-hand turn, but the seats have been really polished and are very, very slippery. So if you look at the diagram, Mark, who is if we mark the passenger's position as marked with a solid circle, the driver with the X, if we watch the driver's motion, their body is going to try to take them in a straight line. So they're going to want to go this way. Now notice they don't continue to go that way, and the reason is at this point right here they hit the door, and when they hit the door applies a force to them. Now the door is going to push in toward the center of the motion, so the door is going to push the person this way. That makes them continue to move in the circle, but notice that they're stuck up against the door during the entire time. Okay, now if we have the passenger marked out here, now again the seats are very slick, so the seats are not going to provide any kind of real force. The passenger's going to try to maneuver in a straight line. It's going to try to stay in a straight line because of the law of inertia. Now, passengers in blue, if I mark a straight line for the passenger, this is essentially where they would go. Now, as long as there's nothing else to push on them, they're going to continue to move in that straight line. So what happens is they continue going straight line, straight line, straight line, even though the car is turning, and they start to slide across the seat. Eventually, right at this point here, they hit the driver. And so now the force from the driver is also going to push the passenger in toward the center of the circle. And therefore, the passenger will also move from here in a circular path, and they will be up against the driver while they do that. Okay, so this place where they make contact is point B here. And from there on out, their motion is essentially going to be in contact with the driver. They'll be stuck right next to the driver, being pushed inward toward the center of the circle by the driver. Okay. Now, at every location, the force on the passenger and the driver again is going to be in toward the center of this circular arc. Okay, toward the center. Now the word for toward the center is centripetal. A lot of people feel like when they're in the car, well, I must have gotten pushed out toward the outer edge and got pushed into the door. But again, it's not an outward force pushing you. It is your inertia is carrying you in a straight line, and then to keep you from moving in a straight line, the door actually has to push you inward. So in number 6, the collision between the passenger and driver can best be explained by, it's not an outward force. Okay, no outward forces anywhere. Outward centrifugal is not correct. Outward force. No, nothing pushed them toward the outside of the circle. Their inertia tried to carry them in a straight line. The best overall fit is the passenger traveled straight ahead in a straight line by the law of inertia, and then an inward force pushed the driver into the passenger. And that kept the passenger moving in a straight line, hopefully, if they were stuck up against the seat, and kept them both moving around the curve. Okay, so we have these two different terms that get thrown around, and only one of them is correct. It's very difficult to understand which one is correct, but the two words are centripetal and centrifugal. Now, centripetal means, literally from the Greek language, it means center seeking, thus toward the center. Centrifugal means an outward seeking position. Now, there is no such thing as a centrifugal force. So you want to get rid of that term right now out of your mind. When you're in the circle and you're being moved around by the various forces, it often feels, you get this sensation that you're being pushed to the outside. But in reality, you're being pushed toward the center of the arc that you're moving on. Okay, so the correct term is centripetal. All right, so inertia is what tries to make us move outward in straight lines. Centripetal forces are what's going to make us move in circles. All right, we'll look at some more applications in the next video.